Okay guys, welcome to the Wireshark basics on TryHackMe. I actually teach you something about the Wireshark 2. I think the Wireshark 2 is actually the most important things of cybersecurity. Because of this Wireshark, we are using the packet analyze. So packet analyze is that meaning there's two computer and the computer has some communication with that. With each other, so we have to know some things, how the computer is using communication or something like that is over there. So another things I think we have to be get about there. The Wiresharks for using some network have to use ports, IP address or something like that. So I think it's really cool, and I think it's really needed to be. We have to learn of cybersecurity. So this video is just for the Wireshark basics, but I will record the old Wireshark CTF or something like that challenge on TryHackMe. I will record all of us, and I got to the playlists for Wireshark. And if you're zero to Wireshark, you have to be like a medium, or you have to be really good at for Wiresharks. If you watch all of videos, this playlist is a Wireshark playlist. So first of all, we have to know about it. What is Wireshark? Wireshark is a tool used for creating and analyze PCAPs. The PCAP means our network packet capture files. It's commonly used as one of the best packet analyze tools. In this room, we will look at the basics of installing Wireshark and using it, perform basics packet analyze, and take a deep look at each common networking protocol. PCAPs used at the room have been sourced from the Wireshark sample captures page, as well as captures from various members of TryHackMe community. All credits goes to the respective orders or something like that. Okay, read that one and move on installation. Okay, let me go installation. The installation Wireshark is very easy. Typical comes on Wiki GUI wizard. You can install Wireshark is over here, but we are already using Kali Linux, and the Kali Linux is already have a Wireshark, so we don't need to actually install the Wireshark. But if you're using Windows or Mac or something like that, you can install on Wireshark website. So for more information about Wireshark, check out the Wireshark documentation. Okay, let me check it. So there's an Wireshark documentation maybe we have to be using in this challenge room. Alright, this time's go for Wireshark overview is over here. So the first screen we read it by opening Wireshark. That main page is specify interface that will apply filters and narrow down the traffic that we're capturing. So if you go here and you say Wireshark, alright, let me minimize that. So like that, I think it's fine. Yep. Here we can see that I have multiple interfaces from your main. First I have from the whatever we want to perform, like a capture interface or load PCAP for analyze. It's useful to note that graphs next to interface means show activity on the interface. If an interface has a flat bar, it may be useless to attempt to capture on it. As no data the interface are being picked up the Wireshark clean. So leave packet captures is if we begin navigating the green ribbon on the Wireshark and select manage capture filters, we can view a list of available filters. So there's I think is you don't need to select the filter, it will only help to bring down number. Okay, the capture, this is only brief introduction of task 12 we got this over here. So I think it's will like Wireshark overview. This is a Wireshark overview, we can use that. So it's really close to run it. Just come over here and hit it. So now it's time. Now it's start to listen the IP address, TCP. I mean it's ports or something like that, and that means we got something is over here. There's some packet analyze. So I'm gonna actually close this because I think they give us packets for analyzing. So I think it's time to go collection methods. Okay, let me say collection methods. What is collection method? the collection method overview, some things I would think about before going hard first in attempting to collect multiple live pack captures. So begin by starting with a simple capture to ensure that everything is correct to set up your successful capture traffics. So we have to be using this over here, I think, is a collection method. So collection method is really cool because there is so many packets. I'm gonna show you how to be using it. So let me say download this and open it. So you can use, there is a 531 yeah, 531 packets is over here. So we have to be analyzed. There's some queries, some important things for us. So we have no time to analyze all of these packets. So that means that when you get this here collection methods, we have to be using some network tabs and doing it, or collection methods overview or something like that. MAC floats, ARP poisings, for actually is MAC address. So that means that if we are thinking about if we have to be find the MAC address, we have to be work on ARP poising. So let me go filtering captures. Yeah, there's some important things we have to be added for operations or some filterings, basic filtering on Wireshark. If you go to Wireshark or something like that, let me do it one more time. Alright, here. Okay, there is some apply display filter you can show like that. Yep. So if I say the IP here, the Wireshark give us some options. What you want to use. Alright, is what you want to use of the basic filtering. Do you want to be AP, ADDR, or options, or something like that? Some routings, who ports, or AP v6, like that. That means we have to be using for filtering the IP address. We can use AP address. Now AP ADDR and equal and give this IP address. That means for example, we get the attacker IP address, so we have to be check it with just looking for attacker IP address, which protocol he or her use, which protocol he's used, I mean that like that. So what is password, username, or which payload, which tool is using. So that is really cool for us because we got all of things are so basics with this filtering. So another things for IP in this industry, we have to come over here and say IPCRC. That means this IPCRC is giving us actually is like that. I'm gonna say, but if you're gonna say IP dot like that, no, like that. Alright, cool. You can use that. There's a fragment, geopipe, OPT, and then there is an CRC. You can use all of there. So that means the source operations. So if you got this equal is like that, and give the source IP address is over here. You can look like that. And yep, it gives this IP address, but there's no IP address because we are using now the ARP packet. So our packet is just for MAC addresses. So let me go here, and there's an filtering TCP protocols. Last filter we will converting this protocol filter. This allows you set the port the protocol to filter by can be handled while trying to keep track on the usual protocol port being used. It is worthwhile to mention the Wireshark can filter by both ports number as well as protocol names. Syntax is just giving us for filtering the it's actually, let me say, for example, we have to be filtering port. We have to say TCP port or like that, EQ, and then give this port. And for example, is 80 port. The 80 ports protocol name is HTTP. You can use that, or if you don't want to be use that, you just say the HTTP or something like that here. Alright, that's cool. For example, if you can say HTTP, it's giving us same things. It actually is equal to with UDP ports, because of filtering UDP port you can also UDP ports changing prefix from TCP to UDP. That is the end of the filtering this task. However, I recommend to play around with filters or priorities on your own, or you read them on task to task 5. So I think it's time to packet this action. Alright, now we have the 7 layers of the OSI model. This is really important network. And then there is an application, presentation session, transport network, data link, and physical or something like that. You can read a lot of things here. First of all, we have to be getting details for packets. You can double click on your packet, capture, open its detailed packet consists of 5 or layers. The OSI model we will go there the HTTP packet from a sample capture. There's an giving us a hypertext transfer protocol. Looking above the 7 distinct layers: packet frame, packet source, mega source, IP address, protocol address, application, and then application data. This is for just one givings is layer 1. Okay, let me starting with layer 1. Layer 1 is a frame. This will show you what frame or packets you are looking at, as well as detail specific physical layer of OSI model. So that means, or if you come is a frame tabs on the like that, there is a frame tabs. So that give us the packet you are looking as well detail specific physical layer. So another thing is source MAC. The MAC is a layer 2 is here. Yep, let me that, and there's an Ethernet 2. That means our MAC address is hidden it. So there's a destination way. The MAC address is here, and the source MAC address is the second one. So the another things the source is giving us IP address. The another things we have to be know about our Internet Protocol version 4. That means our IPv4. So that is giving us the IP address. If you come over here, you can say ifconfig like that, and there's an IPv4. It's giving us this. Alright, let me do it bigger than. Yep, now it's time to, I think it's cool. We'll come over. No. Alright, is there any? No. Cool, okay. No, we don't need the actually the VPN. So, alright, I think it's time to go ARP traffic, and I'm getting some. Alright, here ARP overview. Yeah, I think it's fine. So I think we got this ARP task file, and we can use the analyze the ARP traffic. Okay, when you got the one, there's a startup is over here. So first of all, I wanna be look at over there. There's too many packets. So I think that means or we have to be using the another filtering. This is over here. So let me close that, and ARP or address resolution protocol is layer 2 protocol using the IP address with the MAC addresses. They will contain request message and response messages. So to identify packets message, header will contain of the 2 operation codes. There's first of all is request, and the second one is reply. So request and reply, there are the different things, have a different things of it, the Wireshark. So below you can send up capture the multiply ARP request and replies. Okay, there's an ARP request and replies, there's something like that. So I think it's time to go ARP traffic overview here. Now let me check the ARP request packets. We can begin analyze packet by looking for the first request packet. Look at the packet details. Alright, let me go. Alright, this is we're on Wireshark packet 1, right? Yep. Okay. There's is there an you can use over here intern protocol. And is there any problem? Let me check it now. So yeah, there is an okay, below on, yeah, like that. Yep, there's a frame, and is the frame 6. It's giving us something like that, and the Ethernet and the address resolution protocol. This is our just for requests. So if we get this, there is an opcode and the target MAC addresses. So they are giving us target MAC addresses is a 00 or something like that, and this opcode is giving us the request number. So looking at the packet details above, the most important details of packet outlined in red. Opcode is a short operation code and will tell you whether it is a request or reply. So I think as a request, if the opcode is equal to 1, that means there's a request, and the opcode is equal to 2, that means the opcode is equal to reply. So that is really cool. I think we have to be know about it. So another things are replay packets. If you get this, so let me go to, alright, for example, nope, good, nope. Alright, let me, opcode request is 2. There is no opcode request is 2. Let me look over here. For example, the frame 3 now is frame 3 is now address resolution protocol. Okay, I'm gonna say ARP here. So now we got this ARP, and all of us is request, because just source is over here. Let me go over here, and yeah, you can use, for example, is here the opcode is equal to, that means there is an source is Hawaii and destination is CFR or something like that. So practice our packet analyze. Now that you know the our packets are normal traffic look, let's dive on the exercise. Start the attack box. There is an attack box? No, there's no attack box. Oh, we don't need the, alright, it's cool. We don't need the attack box because we are already using Scala Linux. So what is opcode for packet 6? Okay, let me go packet 6 here. Alright, there's an opcode is request 1. What is the source MAC address of packet 19? Alright, let me go here and MAC addresses. So you can use user MAC addresses over here. Let me copy the value. Alright, you can paste here. That means you can correct this answer. The MAC address is equal this. So what for packets or reply packets? Okay, yeah, it's actually okay. Alright, I got it. It's actually asking us the reply packets, but if we come over here, there is an for example, yep, we got before, I think. Yeah, we got before. The for example is like there. Let me check it. That means if there are packets from, let me show you. Alright, here the reply packets is equal to, yep, not like that. I'm gonna use this source, yeah, like that. Source is equal to Hawaii like that, way to destination is equal to CFR is 18 C2 and 72. That means there's a source is if equal to Hawaii and destination is equal to CFR, and like that. This is a reply packet, so you can use that with destination over here. Alright, let me do it. Hey, alright, cool. There's an that means we can use that like, alright, okay, I'm gonna be use that select it. So yep, there's an 76, 400, 489 and 520. Yep, there is an what is for packets or reply packets, we use that with like that. So what IP address is at this MAC addresses. So we got this from packet 19. That means we time to go packet 19. Like, alright, I'm gonna is there alright, let me close it. So do it. Start one more time. Say ARP. Yep, there is an giving address resolution MAC address, and there's a sender MAC address is equal to this MAC address, and this MAC address has this IP address. Yep. Now I think it's yep, like that. Yeah. Alright. I'm gonna say flow, not flow. We can conversation filter Ethernet. Is there any problem because there is no? Alright. Is it the same? Yeah, it's the same. But I'm gonna use ARP one more time, and there's an the port is using it, so okay. Alright, I'm gonna be check IP address is equal to 10.281.23 and 1. There is no IP address is like that. Okay, let me check it up one more time. So let me go 19. Alright, Ethernet 2 trailer destination frame. The hiddeners. Alright, cool. Let me go ICMP traffic. So, alright, I think we can close the ARP traffic. So, time to go ICMP overview here. I'm gonna download task file, and this is on DNS and ICMP, right? Okay, cool. There's an just 33 packets, so I think it was easy to us. So there's some protocol we have to be look at. There's ICMP and DNS. Now we have to be using just ICMP. That means I'm gonna use like that. It will be fine for us. So let me go ICMP traffic overview, ICMP requests, and ICMP reply. So alright, let me check this. What is type of packets for? Alright, let me go types packet 4. There's an internet control message, so type is equal to 8. So this was easy, I know about it. So let me go to 4.5 and it's equal to 0. So what is timestamp for packets 12? Only including month, day and year. Note, Wireshark bases time zone device time zone. If your answer wrong, trying the day more or less. Alright, I'm gonna be check this packets 12. Yeah, here. Alright, I think it's time to get Yep, there's some data for us. I think it's not for us now. We have to be look at the yep, here we have to be look at their Earth Day or something like that. Yep, there is an arrival time, May 6, 2013. What is full data strings is packets 18. Alright, let me go packet 18 here. There's data. Let me copy this with value, so you can, if you're gonna paste there, that will is the correct answer for us. So there's TCP traffics for us. So there is no actually using some pcap file, so it means we have to be read it so directly. So TCP overview. TCP or Transmission Control Protocol handles the delivery of packets including sequencing and errors. You should already have an understanding of how TCP works. If you need the refresher, check out the IETF TCP documentation here. So below you can see sample of mmap scanning port ADM4044. We can tell the port is closed due to RST and ACK packet in RAT. So when analyze the TCP packets, Wireshark can be very helpful to color code packets order of danger level. If you can't remember the color code, go back task 3 and refresh on the Wireshark. The user's colors match packets. TCP can give useful insight on network analyzing. However, it can also analyze the numbers of packets. It says this is where you might need to use other tools like RSI, net witness, or network miner, or filter or further analyze the captures. So TCP traffic overview is here. A common things that we'll use analyzing TCP packets is known as TCP handshake, which you should already be familiar with. It includes series of packets seen ACK and ACK, so that allows devices to establish connection. If you have to be analyze the TCP packets, is for analyzing TCP packets, we will not go into individual details of packets. However, look at the behaviors the structure of the packets have. So below we see packet details for SIM packets with that mining things that we're looking to TCP packets, so sequence number and acknowledged number. Alright, okay, you can use transmission control protocol like there, and there's a sequence number and acknowledged number here. Then the flags tabs is over here. In this case, we saw the port was not open because the acknowledged number is 0. Within Wireshark, we can also search and sequence numbers, added preference protocols, TCP, and unchecked boxes, so like that. So read this about the task 4.9. Alright, time to go DNS traffic. So DNS traffic is DNS traffic is equal to actually username, password, Diagram protocol, user protocol, or all of things is over here. We have to be look at. So I'm gonna be close it, and alright, it's the same. Alright, let me cool. It was cool. Let me say destination, like not destination protocol, like that. There's an just 1, 2, 3, 4, 5, 6, and 7 DNS packets we have. So below, alright, DNS or domain name service protocol is use the resource name IP address. Just like the other protocols, you should be familiar with DNS. However, if you're not, you can refresh with an IFTP DNS documentation. There are a couple things outlined below that you should keep in the back of your mind when analyzing DNS packets. So query response, DNS reverse only, and UDP is over here. If anyone does the outplace taken packets should be looked at the further and should consider suspicious. Below we can the packet capture with multiple DNS queries as RESP size. Instead of looking for the packets we can see that they are occurring. This can be helpful when you have many packets to unit to identify suspicious or unusual traffic quickly. DNS traffic overview. DNS query. Looking at the below query like that. Alright. Let me say for example here there's a domain name system. You can use it. The most important things for us, there is a user diagram protocol. Alright, let me close this tab and read it. There is an UDP 53, which means these packet pieces are checked. If TCP is done, should be considered suspicious traffic and needs to analyze it further. We can also look at what is querying as well. This can be useful. The information will store what happened. So there is an if you're gonna check it, user diagram protocol, there's an you can show over here that the SRC port is equal to 53. So if you're gonna check the queries here, alright, queries, alright, answer is actually here. This is giving us ID RPI is here. So DNS response, below you send response packet is similar to query packet, but includes answer we can use the verified query. Okay, practice DNS packets analyze. Alright, what is being queried packet 1? Alright, let me go Wireshark and use packet 1. Then queries is equal this, and this question's answer is equal this. What site being queried is packets 26, the packet 26 is over here. So there's an queries for us, and the queries is equal to www.wireshark.org. Alright, what is transaction ID for packet 26? And let me go 26 one more time, and you can use here all of things you have to be using like that, timestamps or something like that. But there's some checksum is, you can look over here, you can see it was over here, and this query is over here, and the another things, the transaction ID is into the domain name system query. So transaction ID is equal to 0x2c80. No, 58. So this is that was easy. I think it's time to get some hard to HTTP and HTTPS traffic is over here, because the HTTP traffic is really cool, and that was the most hard packets, this HTTP packet. So now I have to go close the tabs and download task files for HTTP cap. Alright, here we got TCP, HTTP or something like that. I'm gonna tell you guys that before, if you are using the HTTP for display filters and enter, this is just giving us HTTP. What we're using is something like that. Alright, HTTP traffic overview. You should already have a general understanding of how HTTP works before completing this room. However, if you are in a refresher, you can read the official paper by IFTP and HTTP methods. HTTP is one of the most straightforward protocols for packet analysis. The protocol is straight to the point and does not include any handshake or prerequisites before communication. Above we can see the same HTTP packet. Looking at the HTTP packet, we can easily gather information since data stream the encrypted like the HTTP counterpart, the HTTPS. Some of important informations we can gather from the packet request URI, file data, and server. Now that we understand the basic structure of the HTTP packet, we can move looking at the HTTP packet capture gets on with the packet. So there is a hypertext transfer protocol. You can use that. Then there is a GET. They're using GET for download HTML or something like that. Alright, you can see this, enter all of it. So there is some get get packet one more time. HTTP directly is using here. There's just 43 packets that are that means are really cool, because we don't need to go somewhere. Okay, practical the HTTP packet analyze. To get understanding of the flow of HTTP packets and get sound of white packets, we can analyze the HTTP cap file. Go to folder root rooms Wireshark and attic bar or something like that. And after opening pcaps, you can see just simple HTTP packet captured a few requests. Navigating deeper to impact packets capture, we can look details on HTTP requests. For example, packet 4. Okay. From this packet identifies very important as this request your response. So we can use some Wireshark built-in features help digits the organized bar analyze. We can be looking to very useful feature on Wireshark organized for protocol hierarchy. Let me go navigate to statistics and protocol hierarchy. So here I think we have to navigate statistics and protocol hierarchy. Let me go here, and there's a protocol hierarchy. You can use this. So there's giving some percent packets and percent bytes. So how many bytes is using? There is something like that is giving us. It's really cool. Then other things we have to be using export HTTP, navigate this file, export object, and you just looking for HTTP or something like that. So, alright, let me answer this question. What percent of packet originate from domain name system? And what endpoints the ends with like this ports, the sockets, and what is user agent listed as for packet 4? Alright, what is percent packets originate from domain name system? So if you come over here and say HTTP is over here, you can use some different things is like there. Let me go to get download HTML. I think it will be good for us because there is an download HTML some packets is using there. So that means we can use actually using for this Wireshark. It's really cool to have to be gathering information to some packets analysis. So there's an HTTP that tags HTML, and there's an XML file in the Google Drive. There's another things. We got it. So that was cool. Let me go there. Okay. So what is user agent listed as pack 4? There's a pack 4. Yep, there's a pack 4, and it is asking actually is what is user agents is listed. All right, that means we have to go actually hypertext transfer protocol because we are using some HTTP now, and there's a get the download HTML, and yep, that was like that, just like that. And this host is equal to atrel.com. Is there any question for? Yeah, there is an for, but it's for this. Not like that. Where is why? Yeah, here. All right, cool. So there is actually user agent listed here. So there is an user agent listed. Let me check it. User agent listed. Alright, internet protocol. There is that will user agent. Alright, we can use like that. User agent. So let me enter it. We have packet list. Packet size is yeah. Alright, let me do it one more time. Then this is giving us nothing, so that was cool. I'm gonna be cancel it. Then I'm looking for user agent. Yeah, the user agent is on the hypertext transfer protocol, and this is equal this. So let me just copy this with value. So that is the answer of this question. So looking at this data set, what is the full request URL from packet 18. So let me go to from packet 18. So it asks us a request URI is over here. If we want this, if we want to get this, so just come over here and now is looking for data stream to URI from. Alright, there's a request URI, and if you have to copy this will be answered for this question. Sure. What domain name was requested from packet 38? Let me go 38. There is an you can use like there. Yep, request URI is equal to http www.atrel.com. So this is a domain name is equal to atrel.com. Looking at the data in what is full request URI from packet 38. So there is an download.html is using for us though, so we have to get at this with download.html. So there's an HTTPS protocol is I think it's same too with HTTP protocol, and there's another things around conclusion. Alright, let me go HTTPS to get this and stop the video. Alright, let me go. There's a snake oil 2 zips. Let me go here. So there's an RSI snake oil. Alright, let me go first of all. Yep, here. Alright, let me save, and pcap file is over there. So there's an TCP SSL or something like that. We are on the HTTPS, right? Yep, there's an K for us. Not like, alright, there's no, we do not get this. So alright, let me go back ls and go downloads. Alright, unzip single zips. So there's an cat RSI. Nope. Alright, this is giving us some ID RSI. So HTTPS traffic overview is like that. There's a transport layer security. They are using transport layer securities actually. So this SSL will 3, SSL will 2, or there is giving us session ID on the handshake type. Is something important information for us that's gathering this. So what alright, I'm just looking for actually. Alright, oh, we have to be added some we can confirm from packet details the application data encrypted. You can use RSI conduit or ordering. Alright, like that encryption unencrypted in order load and RSI navigate, added preference protocol TLs, and add this. Okay, so that will give us the some. Alright, cool. I'm gonna use that to. Alright, let me copy this and go cyberchef. Give this. Nope. Right, let me say base 64. Give this. Code it. No, it's bullshit. So right. Alright. It's giving us already here. Alright, let me check it. There's an readme. Oh yeah. Okay. Let me go edit preference. Alright, edit. There is an yeah, preference is here. So alright, protocols and TLLs. Alright, let me go. Um, protocols to TLS. Scroll down, down, down. Yep, TLS. What is the next step? And add this. Add there some things. Or RSIK list? No, I think not. Debug file. Let me go downloads. Alright. Already access? Oh, there's an already access? Oh, okay, we don't need this. Alright, we don't need to get this. So that was cool, okay. Alright, I'm gonna say HTTPS here. I think it's time to do it. Alright, there's no HTTP. Nope. HTTPS. Nope, there's no HTTPS. Actually, there is an SSL Vault 3 or something like that. Yep. Alright. Looking at the data stream is packet. Alright, let me go packet 31 before, and looking at data stream, what is full request URI? Alright, is here. Transmission, transport layer count security, SSL Vault 3 like that. So this is a hypertext protocol is using there. So alright, there's a flags for us, but it's bullshit, I know about it. So options, new operation SAC. Alright, entire protocol. Yep, I like that. For example, is there any problem? I think yeah. I think we have to be at this, but there is already. Alright, let me say. No, there is no HTTP and there is no HTTPS. Okay. Let me do it one more time. Preference. Protocols. TLS. There is an browse. Yeah, there is an already exists. Yeah. Alright, let me close. Oh my goodness. Alright, here. Yep, there's an for us. Okay, look at for example, there's a packet 31. We can use TCP stream. Yep, let me go TLS. Nothing giving us. So there is an is already transport layer security as a workout hypertext transfer protocol. So encrypt application data. So alright, let me copy the value and for example okay, time to go cyber chef? I think it's not, but let me try it. No, it's bullshit. Yeah. Alright, there's an HTTPS analyzing the zero log and exploit pcap. So I think its conclusion is over here. I'm gonna say TryHackMe Wireshark, yeah, like that. Yep. Now I have to go the all of things is over here and record the video, guys. Alright, this video will be end here.